So the next presentation is paper number 71, Systematic Classification and Evaluation of Automated Progress Monitoring Technologies in Construction. So Varun, Kumar, Reja is here. Floor is yours. Come over here, please.
Hello, good afternoon, everyone. So I'm Varun Kumar Reja. I am a joint doctoral candidate from IIT Madras and University of Technology, Sydney. My other co-authors are Megha S. Pradeep, who is a master student at IIT Madras, and Professor Koshi Varghese, who is my guide. So this paper is actually on a systematic classification of an evaluation of automated progress monitoring technologies in construction. And it is not directly related to my research. My research is on computer vision based progress monitoring. But this is a paper which we got motivated to write because we had interaction with Indian construction industry. And we talked with them about what are the progress monitoring technologies or techniques they have been using in the construction projects, their construction projects. So even large companies like Larsen and Toubro, which is one of the best companies in India, they told we use maybe a LiDAR-based progress monitoring technology or a drone-based progress monitoring technology. Most of them were social media-based, maybe WhatsApp-based progress monitoring, where the planning engineer has to convey the data to the his manager from messaging apps of how much progress was made on the structure per day. So we felt like there is a gap between the academia, how much research is being done in academia about the progress monitoring technologies and platforms, and the industry. So the background, progress monitoring, as we all know, is very important for any construction projects. It helps in planning for manpower, machinery, and materials. And by effective progress monitoring of any construction project, we can save time as well as cost. So we have a lot of progress monitoring technologies, as you can see in this picture, but they have not been classified. The last time they were classified was by Kumar in 2016, who classified these technologies in 5 domains, which are enhanced IT, geospatial imaging and AR, and commercial softwares. So this was the last classification which is available. And also the factors which how to use these progress monitoring technologies on specific construction projects was last reported like 7 factors. And this was the paper which talked about them. So the core objective of this paper is to identify and classify, to evaluate the progress monitoring technologies which are being used in construction, in academia, and to list down and categorize the factors that can enable appropriate classification and selection of these technologies for specific use case. So the methodology followed was a systematic database literature search. And these were the collecting studies from the database, selecting and evaluating relevant literature, and analyzing the findings, finally reporting the results. So going into the classification, based on the literature and meta-analysis, we got 17 progress monitoring techniques which were identified. And these techniques were classified into 6 major categories based on the technology used. These are first, the ICT-based conventional technologies. Second is the tech-based methods, geospatial-based methods, BIM-based or associated commercial software-based methods for progress monitoring, computer vision-based approaches, and extended reality. So I'll talk briefly about one by one. Like the conventional ICT is like the mostly used methods, like mobile platforms which work on some backend computing, which includes Excel sheets and most basic techniques of progress monitoring. And these are like used in the majority of construction sites because primarily they are very low cost means and quick means of sending information. And but the cons about them is that lacks visualization. Second are the tag-based methods. These methods are like QR codes, barcodes, or RFID that can be put on construction precast based methods. So they are mostly used in a project where materials or machinery has to be tagged or classified there. So the installation is manual and laborious. So that is a con for that. Next are geospatial technologies. These are not explicitly used, but they are clubbed with other technologies to be used with for progress monitoring. They are mostly used to identify space-time conflict, and they are not very accurate for indoor construction environment. Fourth is the BIM-based methods, where the BIM-based technologies are being used for as-built versus as-planned data progress comparison. And the quantity estimation from a BIM-based technology is pretty easy, but mostly the as-built model is not available. So that's why currently technologies are being generated for converting automated data from a spine model to BIM model. The next one, which is a very hot topic, is computer vision based method. So this is the recent paper which we published, and we define the computer vision based method for progress monitoring in 3 steps. First is data acquisition and 3D reconstruction. Second is as-built modeling, and third is progress monitoring. So scan to BIM is one of the evolving area in construction, and currently it has not reached the level of automation for on-site implementation. There are a lot of gaps where, for example, in the area of noise removal, actual construction sites have a lot of noise, but particularly the research we are seeing expects noise-free data for identifying points, identifying elements from the point cloud. The last one is the most recent one, which is the XR-based technologies, which is a group of virtual reality, augmented reality, and mixed reality, which is being used currently for progress monitoring. And these immersive environments are really good for visualizing that data or the progress of the project, but they have some issues that can be related to the cyber sickness also. So finally, we come to what factors a construction site has to see while selecting a progress monitoring technology. So we divided the factors into 2 types. One is the qualitative factors, and another are the quantitative factors. The qualitative factors the qualitative factors include the accuracy, the cost, time efficiency, and the operating range. And the quantitative factor includes preparation required for progress monitoring, automation level, the training required, statutory requirements, project type, mobility requirements, and so. So the utilization of factors has to be judged while deciding on a progress monitoring technology suitable for a project. The project characteristics, how the project is, the cost allocated for progress monitoring or project management has to be taken into account while selecting these technologies. So to utilize these factors, we have to put weightage to each of the factors. So we did this case study based on one particular technology, which is the computer vision based technology. And we mapped the various sensor mounting techniques like fixed, manual, UGV, UAV, and the various data acquisition technology selection like lasers, range imaging, laser scanning, and photogrammetry. We identified factors for each technology and then gave resulting rating based on which of the technology would perform better. So this is a small framework for computer vision based progress monitoring in construction. This concludes my presentation. The highlights are like we provided a systematic review for progress monitoring techniques, identified in this paper limitation and benefits for each technology, and also identified the factors affecting their selection. So these are some of the references. If you have any questions, I will be happy to answer.
So we have 5 minutes for some questions, if there's any.
Varun, thank you for the great presentation. I mean, for people who want to get into automated progress monitoring, this systematic analysis is perfect. Wondering if you also looked into the impact of process of implementing automated progress monitoring. One process. The other one is how much preparation needs to go into making sure BIM and the schedule have the right granularity for the purpose of tracking. And the last one is who purchases the software at the end of the day. If it's the owner, are they looking to an end-to-end solution? If it's a contractor, are they looking to a software or software plus hardware components? Can you, if you've looked into process and the way the technology gets acquired and its impact on its implementation, it'd be great if you can please share that insight. Thank you.
Yeah. So, sir, talking about my experience on what you have asked. So we have this collaboration with the company called as Larsen and Toubro, and what they have been asking is, like, after telling them about the various benefits of automated progress monitoring technologies, they ask, okay, Varun, so what should we do? How should we start? If we want to adopt computer vision based techniques, should we just buy a drone and just try on the site? What are the data required? So the companies are really interested in to know, but for systematic adoption, I think they will have to set up some guidelines on how, what is the level of details they require to capture. For example, in one of the construction companies just want the floor-wise data only for the structural elements. Another company wants even a minute detail of if the electric plug is installed or not. So the solutions are available, and we have a lot of literature which is being published. But how to take that literature and how to convert into product for a particular company, that depends on the use case.
Questions? Thank you very much.